Welcome 8th grade, multiplying rational numbers. Write each number as an improper fraction. Remember our triangle method. 3 times 2 is 6 plus 1, 7 over 3. Alright, remember our triangle method. 15 over 8, 17 over 5. 1820 over 3, 43 over 8. These are all important things to know how to do, all right? Especially as we multiply rational numbers today. Today, learn to multiply fractions, mixed numbers, and decimals, doing all three. It's more about memory than about anything else. So, repeated addition. 1 plus 1 plus 1 is 3. 4 plus 4 plus... Oh, their denominators, they stay the same. All right, so that's the same as multiplication. 3 times 1/4. I, if you'll remember, like to write it like this. Oh, numerators times numerators, denominators times denominators. We get our answer. We get our answer. Okay, we can always put a number over 1 to make it a fraction without changing anything. Notice that multiplying a fraction by a whole number is the same as multiplying the whole number by just the numerator of the fraction. Okay? If the signs of the factors are the same, the product is positive. If the signs are different, the product is negative. Our integer rules that are over there on the wall. Hopefully you took a picture before you left. All right? Signs are the same, positive. Signs are different, negative. So here, look at this one. I would really suggest instead of having -8, let's do -8 over 1. 8 times 6, well, there's -48. 1 times 7, that is 7. Then write the answer in simplest form. That's where you have to do a little bit of work. 48, we're going to do the division, divided by 7. All right. So it'll go in there 6 times. 42. Subtract by 6. We got to the decimal, so we stop. The number on top, that is our whole number. The number down here, that's our numerator. And the number we divide by, that's our denominator. The denominator for your mixed number should always be the same as your denominator for your improper fraction. And don't forget the sign. -6 7/6. Not too hard to do, just a lot of steps. A lot of chances to make an oopsie daisies. All right, we do our multiplication. There we get it. All right, then we do our division and we simplify and get our answer of 6 7/6, or 6/7. That's negative. Now, there's one more step we thought we'd add in here. If we think about this as 2 over 1, we need to think about this as a improper fraction. Do our triangle method. 15, 16, 16 over 3. We are multiplying. That's 32. This is 3. So we can do our division. 32 divided by 3, knowing we're going to stop at the decimal. 1. Oh, there's our 3. 0, 2. It will not go into 2. Got to put a 0 to hold the place. Some of you still forget that. Hey, where did the decimal? That's our whole number. That's always our denominator. It's going to be the same as what this was over here. Then our numerator here is 2. So 10 2/3 is what we have. Make it into a mixed number, do your multiplication, or make it into an improper fraction, do your multiplication, then make it back into a mixed number. Let's see how they did it. All right, we do our multiplication. There we go. And they've done all that work. Now we get back to 10 2/3 like we had. Here again, I'm going to save a step. I'm simply going to put negative 3 over 1. Oh, that means 8. That means negative 15. Hopefully some of you are getting to the point where, hey, I can kind of think this out in my head. Oh, that means I have 1 and 7/8, knowing it is a negative 1 and 7/8. Okie doke. That is what we need to remember. We do the multiplication. I always put it under a 1, so numerator times numerator, denominator times denominator. We do our work. Okay. Negative 1 and 7/8. Here we are, another one where we start with a mixed number. Use our triangle method. That's 45. So this is 47 over 5. This is 4 over 1. That number is 4 over 1. We're multiplying, so we get a 5 on the bottom. And on top, I can't do that one in my head, I'm sorry. All right, that's a 28, and the 2, 16. So 188 and 88. All right, we need to turn that back into a mixed number. So 188, we're going to divide by 5. My gracious, I wish my smartboard worked better. All right, so the 188, that's inside, the 5 is outside. It'll go in there 3 times. That's 15, 38. All right, it'll go into 38 7 times. It's 35. The number up here is the whole number, 37. The number you divide by, notice that was in the numerator or denominator. It always stays in the denominator. And then whatever we're left with here when we get to that decimal is our numerator. For some of you, it may be a blessing to have this lesson like this because you can go back again and again and again and look at the process. Don't forget to do that if you need that help. All right. All right, they talk about doing that multiplication, then they get 188 over 5, and then they get 37 3/5. A fraction in its lowest terms or simplest forms when the numerator and denominator have no common factors. So they're asking you to reduce it to its lowest common terms. They're going to do some with those now. Now, we can say 1 times 6 is 6. 8 times 7 is 56. Okay? But this is not in simplest forms. I see I can divide that by 2, and I can divide this by 2. Isn't 2 over 2 just a fancy one? So we're just reducing. So that would be 3 over 28. Now, 28 and 3 have no common factors. So we have our answer. All right? Now, there's one thing I would prefer to do. If I can see, I can take 2 out of 2. Watch this. If I divide the top by 2 and the bottom by 2, 6 divided by 2 is 3. 8 divided by 2 is 4. 1 times 3 is 3. 4 times 7 is 28. We can reduce before we multiply. You get the same answer. As long as I take 2 away on the top and 2 away on the bottom, I divide them by 2. I divided by 2 on top. I divided by 2 on bottom. I did the same thing. That makes my fraction math much easier. All right, in my opinion. You may like to work it out and then reduce. That is fine. Choose your way that you like. Okay? They say reduce beforehand, but you don't always have to. You can do it like I did the first time. All right, here. I could take 2 times 9 and I could get 18. I could take 3 times 2 and I could get 6. And I realize 18 divided by 6 is 3. Don't forget my negative. One negative, one positive. Answer is negative. Don't forget those negatives. It will cost you lots of points. The thing that I like to see, 2 and 2. I divided by 2 on top and bottom. Divide by 3, I get a 1. Divide by 3, I get a 3. 1 times 3 is 3. 1 times 1 is 1. Oh. Aren't these the same things? Aren't these the same things? We can reduce before, like the red, or we can multiply and then reduce after, like the blue. Your choice, but do it correctly. Okay. All right. -3 is our answer. You see their work. They reduced beforehand. All right. With this one, 3 times 5 gives me 15. 5 times 8 gives me 40. I see I can divide by 5. Divide by 5. Hey, 5 and 5, that's a fancy one. So then I get 3 over 8 for my answer. Okay? Or I can look at it like this. 5 divided by 5 is 1. 5 divided by 5 is 1. I divided by 5 on the bottom, divided by 5 on the top. 3 times 1 is 3. 1 times 8 is 8. Didn't I get the same answer? All right, remember, you can multiply first and then reduce, or you can reduce first, then multiply. Either order works. You're in 8th grade. I want to give you the options and let you do the thinking and work, okay? They like to reduce before, 3/8. I would say that's simpler, but that kind of depends on the person. 7 times 4 is 28. 8 times 7 is 56. Now I know there's going to be a negative in the answer. I see I can divide by 7. I can divide by 7. 7 over 7 is a fancy one. And I get 4. I get 8. Ooh, I can divide by 2. I can divide by 2. Or I actually see something that would be easier. Instead of 2, I can divide by 4 and divide by 4, another fancy one, and I can get 1 over 2, which is 1/2. Then I got to remember, way over here I had a negative. Negative 1/2. Or, what I think is easier, 4, I can divide by 4, that gives me 1. 8, I can divide by 4, that gives me 2. I actually looked at both of those before and saw, hey, I can divide by 4. 7, I can divide by 7 and I get 1. 7, I can divide by 7 and I get 1. 1 times 1 is 1. 1 times 2 is 2. Negative. I really think this is a lot easier, but some people do need to see that. Either option is okay. Let's just work to get our answer. And ours did match theirs. Wonderful. Now, this with decimals is like long multiplication. We just do it out by hand. So I'm going to take the 2 times 2, and I'm going to do my math here. 2 times 1 is 2. 2 times 5 is 10. Okay? I've done all the math that I need to. Now, this is not the correct answer. I need to count 1 spot, 2 spots, right of the decimal, up here in the problem. I need to move it 1 spot, 2 spots. My answer is 1.02. One's negative, one's positive. I know I have a negative answer. You don't want to forget the negatives and positives. There we go. Negative 1.02. And if these are each a half, that would make sense. Our answer is by 1 if we're multiplying it by 2. Don't forget, you count those 2 spots. That tells you start on the right, move 1, 2. Now I have my correct answer. All right. Product that is negative, we do that multiplication, it's there. All right, over here. 0.4. It does not matter if we line up the decimals when multiplying. 4 times 5, that's 20. 4 times 8, that's 28. Plus 2, that's 30. All right. 4 times 3 is 12, that's 15. Now I need to do like I did before. How many places right of the decimal up here? 1, 2. Don't forget the other number 2. There are 3 places. So I have to move it 1, 2, 3 spots. 1.5. 2 negatives make a positive. 1.5 is my answer. They're saying, what is 40% of negative 3.75? That's 1.5. All right. So we do get our answer here. It's all about the process and doing it correctly. So this, go back and watch it as many times as you need. You can drop the zeros after the decimal point, and we get 1.5. Here, just in case you forgot, I will do this one. 3.1, 8, 2, 3 times 8 is 24. Oh, don't forget your placeholder here. Okay, that's 0. 3 times 2 is 6. Okay. Then we have to add these when we're doing multiplication by hand. 6. And we have 6. Okay. Now, 668 is not our answer when we take 0.28 times 3. 1, 2, 3 spots right of the decimal. 1, 2, 3. The decimal goes right here. Let's get rid of the extra stuff. .668. There's our answer. Let's double check and make sure. When they did the math out, 0.868. I may have done something wrong, it looks like. All right, here, 1.012. Joy completes 1/20th of her painting each day. How much of her painting does she complete in a week? So 1/20th of it each day. We're going to take 7 over 1 times that 1/20th. In a week, she can finish 7/20ths of her painting. How much I get done each day times the number of days I have. Easy peasy. All right. 7/20ths in a week. Mark runs 1/7 of a mile each day. What is the total distance Mark runs in a 5-day week? So he's running 1/7 of a mile each day. And he runs for 5 days. I always like to make that number a fraction. All right? All right. So when we do the multiplication, he can run 5/7 of a mile in a 5-day week. They did do what I did. I think you guys are seeing these are pretty easy. Let's go ahead and give it a shot. Bye-bye.